Hey everybody, Dr. A here, and in this video we're going to be exploring an example of analyzing a non-right triangle. So let's go ahead and get started. In the given information, we're being asked to compute the unknown values of the triangle. And we're given this triangle here that is a non-right triangle, okay? And we're told that this interior angle here is 62.2 degrees. This interior angle here is beta, so that's one of the unknown values. This other interior angle here is gamma, that's another one of the unknown values. Now let's look at the three sides. The side that is opposite of the known 62.2 degree angle is side A. So A is unknown, right? The side that's opposite of this unknown beta is a 9-inch long side. So that's a known side here. And then the side that's opposite of this unknown angle gamma is a known 5-inch long side. So what are our three unknown values? Well, we have side A that we don't know. We have interior angle beta that we don't know, and interior angle gamma that we also don't know. But we do have three pieces of information that we do have, okay? So let's go ahead and get started. So because this is a non-right triangle, we know we're going to have to use either law of sines and or law of cosines to solve for some of these unknown values. So let's go ahead and see what we can piece together. If you notice, we have, in terms of what we have this interior angle 62.2 degrees, and then we have its two adjacent side lengths, 5 inches and 9 inches. But what we don't have is the opposite side length, okay? So whenever we have a situation where we've got these two adjacent side lengths with a common angle that is known, let's say we know all three of these, to me, what jumps out immediately is, hey, let's use law of cosines, okay? So watch what I can do for law of cosines. I'm going to say by law of cosines, I can say a squared equals b squared plus c squared minus 2bc times the cosine of alpha, where alpha is the angle that's opposite of side A. Now, let's piece all this together and see what we have. Well, we can say a squared is equal to 5 inches squared plus 9 inches squared minus 2 times 5 inches times 9 inches times the cosine of that angle, 62.2 degrees, okay? Now, does it matter what side I call B and C? No, it does not, because if you notice, you're squaring them and then you're adding those two terms, and then in the last term of law of cosines, you're multiplying them together anyway. So I can solve for A, and if you remember, you got to be careful. When you solve for A, you're going to ultimately take a square root of all of this over here, right? So you punch all this through your calculator, you solve for A, you should get 8.002 inches, okay? And we could just say 8 inches there if we wanted to, because that's pretty close to 8, all right? So that's one of the unknowns, and we can go ahead and maybe check that off since we know it now, all right? Now, what about these other two unknowns, beta and gamma? Well, at this point, you got some options now. You can use law of cosines again, or you can use law of sines, okay? So we can make a note here. We can say we can either use law of cosines or sines to get beta and gamma. I'm going to go ahead and use law of sines, okay? So I'm going to say let's use law of sines, okay? And so law of sines says the following. It says we can take the sine of 62.2 degrees and divide that by that 8.002 inches. And we say that ratio is equal to the sine of beta over 9 inches, and that ratio is equal to the sine of gamma over 5 inches, okay? And so what we can do is we can take this part of the equation and solve for beta, and then we can take this part of the equation and solve for gamma, okay, separately from each other. So if I write this out kind of separately, I'm going to say sine of 62.2 degrees over 8.002 inches equals sine of beta over 9 degrees. And so if I put a little arrow here, I'm going to say beta is going to be equal to the arc sine of 9 inches times sine of 62.2 degrees all over 8.002 inches. So be careful when you punch that in your calculator. You should get an angle of 84.2 degrees for beta, okay? And then similarly, we're going to set this leftmost term that's all constants equal to the rightmost term and get gamma. So I can say sine of 62.2 degrees, again, over 8.002 inches equals sine of gamma over 5 inches. Do a little bit of rearranging. I'm going to get gamma is arc sine of 5 inches times the sine of 62.2 degrees over 8.002 inches. So again, be careful with your calculator. Make sure you're in degree mode, and you should get 33.6 degrees for gamma. Okay, so your final answers are A is 8 inches, beta is that 84.2 degrees, and gamma is the 33.6 degrees. And those are your final answers for this. If you found this video helpful, please hit like and subscribe, and be on the lookout for other videos like this. Thanks for watching.